What's up, good people? It's Jay. I just want to touch off with this before I hand off the receipts for this No Curve Detected Part 2. Any family, any parents that have children know when something is inappropriate. And just because someone is in power, that does not give them the right to do these type of things. You could be starstruck. I don't give a fuck. I spoke to one of my coworkers last night. I said, would you let a top celebrity take a picture with you and your family and rub your daughter's hair like this and touch her shoulders? And she said, fuck no. I ain't tell her what I was doing, but this is why. I already saw this, but she didn't. But this is unacceptable. And this is a big part of the Epstein pedophilia circus ring that's been going on. Keep your eyes open. Tom Whitney and all you brand new Satan worshiping computer earthers, this is for you. Tom Whitney, 30-year veteran pilot, I don't know of what, but what he flew went over the curvature. But he can't prove it. Why can't none of y'all prove nothing? Why I gotta keep coming up here calling y'all out? Basic logic. This is how Satan worshippers are sent back to their God after visiting Stay Flat Media 7. Let's pray for them. Stay flat.
One thing I really want your generation to embrace is that the earth is a closed system. We cannot leave the earth. There's no place to go.
Basic logic. Stay flat.
The earth isn't flat.
Damn. Hey, what's up, good people? Here we are at No Curve Detected, Part 2. This part here is about all the receipts, all the information that is used to base a pilot on flying. Okay? They are measuring it by a flat, non-rotating Earth. Now, by doing that, I would have to simply ask, what experience will you have if you are to fly practically, that's not even a word, I know that, but on a non-rotating Earth? When it's time to go out there and fly on a ball, please explain to Stay Flat Media 7, what kind of experience will a pilot really have?
Oh, 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 it's magic. You know, never believe it's not so.
In the introduction, they flat out say right here, this report documents the derivation, which means the origin, and the definition of linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. Everybody see that? Derivation means the origin. Definition means this is how it's defined. This is how it works. So they're talking about the equations, and you want to talk about the calculus and trig this thing gets into. The equations are based on these airplanes flying over a non-rotating flat Earth. Question: why would this be in any technical manual of anybody if it doesn't exist? I mean, think about it. They claim the Coriolis effect, that snipers have to calculate the spinning of the Earth, the Coriolis effect, when they're shooting at, 1,000-yard shot or something. Yet they don't have to for Mach 1, 2, 3, 4 aircraft. You don't have to calculate the spin. No. This is just about, these planes fly over non-rotating flat Earth. So, Pastor Dean, this is what I heard. They're just doing that to simplify the equations. Oh, really? I'm sorry. I didn't know that NASA rocket scientists and MIT mathematicians couldn't factor in 8 inches per mile squared. I'm sorry, they have to simplify the math. Maybe they missed a class at MIT or something. I don't know. But this is crazy. Now, you can try to dismiss this if you want to, but it's also in the conclusion, the concluding remarks of the report and all the math and the equations. Look at that. This report derives and defines a set linearized system matrices for rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. Let's keep going here. There's your definition of derivation: obtaining or developing something from a source of origin. Why would you develop the equations for aircraft to fly over something that doesn't exist? Let's factor in the unicorn. And he says, guys, we need a flat Earth model. And here's the math for it. Shall we keep going? Notice this: assumptions, meaning things we assume are true. Flat Earth. Coriolis and centrifugal forces neglected. Here's a doctoral candidate who graduated, got his PhD, becomes a speaker to the European Control Council, and he's telling them it's a flat Earth. We ignore Coriolis, meaning the spin of the Earth. It's completely ignored. Here's MIT. Massachusetts Institute of Technology, the top technical school in the country. Or at least one of the top. I'm sure they argue among themselves who's the top. What's this? dspace.mit.edu. Right? Property-based system design method with application to targeting system for small unmanned vehicles. So this is a targeting system developed Massachusetts Institute of Technology, blah, blah, blah. Tells you who it is, the author of this. And then in the description, it says 3 targeting methods were considered assuming a flat Earth. Whoa. Why would an MIT professor, PhD, why would he assume the Earth is flat? The evaluation revealed a descending utility order, flat Earth, and range based upon the system's requirements. I mean, these and aeronautics and astronautics. Flat Earth assumption, mind-blowing. All right, let's get back to our documents, government documents. Just wanted you to see MIT and other doctoral candidates and PhDs saying it's flat and it's not moving. Calculation of wind compensation for launching unguided rockets. So we're talking about rockets by Robert L. James Jr. and Ronald J. Harris, Langley Research Center, Langley, Virginia, Langley Field. I would say pretty important stuff, right? Right. But who reads this stuff? Who stays up all night and all day reading this stuff? I do. All right, technical note. Here we go. Summary: method for calculating wind compensation for unguided missiles. It is derived from which has a greater degree of flexibility than previously proposed methods, blah, 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 blah. And they get into it. So they're telling you, summary, here's what we're up to. trying to figure out how to guide rockets? Yes, sir. Linear aerodynamics, yes. Coefficients with respect to flow, incidence angles are used, launch angles for wind compensation. I mean, it's pretty serious stuff, right? I think you'd probably need to get it right. I know if I was their general or their boss, I'd say you guys better get it right. This stuff's expensive, so let's get it right.
Better work.
Right, it better work. Let's look at this. It says trajectory simulation incorporating the above requirements is presented in reference 8. In addition to the above requirements, this simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry and roll, and the missile position, again, space will deal with that. They don't even, it's not what they're talking about. What we think, what they've told us, and what they know space is, two different things. So when they say it, they don't mean what they've lied about. The missile position in space is computed relative to a flat, non-rotating Earth. April 1961, NASA technical document for calculating unguided missiles, not anything we're sending into space. Just unguided missiles like the V2 was an unguided missile. Let's keep going here. Here's another one. Okay, completely different document. Where did it come from? NASA.gov, right? Unpublished preliminary data, atmospheric oscillations, tells you the people. Georgia Tech project. Georgia Tech, here we go, right? My wife's brother is a professor at Georgia Tech. He would be losing his mind if he heard this, but his own university has been part of this. Under contract, Georgia Tech project, contract, prepared National Aeronautics and Space Administration. So this was in conjunction with their engineers. Engineering Experiment Station, Georgia Institute of Technology, Atlanta, Georgia. The requirements for additional copies. Talks about that. Says the Department of Defense contractors must be established for DDC services or have their need to know certified by the cognizant military agency. So this was not to be passed around. This was need to know. All right. Georgia Tech project, just so you see it. Boom, boom. April 1965. Tells you the abstract, develop present theories of atmospheric oscillations. Blah, blah, blah. I don't have to. All right. A model frequently used is that of, everybody say it, flat, unrotating Earth. The most one can profitably simplify the problem is to consider the isothermal atmosphere, plane level surfaces, and a non-rotating Earth. NASA.gov. Now this is general equations of motion for a damaged asymmetric aircraft. So what they're trying to do is fix equations if a plane loses part of its wing or tail fin or whatever, how to compensate and all that stuff, right? So that's what this is about. And the technical manual gives you this stuff. The introduction, here's the introduction, right? Just so you know, it says, in order to analyze the dynamics of damaged aircraft, the dynamic equations of motion must properly reflect the underlying physics. Now, I want to say that again. I want everybody to pay close attention. They're telling you right here in the introduction of this, and they're showing you a damaged aircraft. They're saying, in order to analyze the dynamics of damaged aircraft and dynamic equations of motion must properly reflect the underlying physics. It must, what we're going to do here must reflect the true physics. Physics. People say, you don't understand physics. Okay, well, these people do. All right. Who are we talking about here? The American Institute of Aeronautics and Astronautics. And here's what they say. Rigid body equations of motion, reference to an arbitrary fixed point on the body. There are several approaches that can be used to develop the general equations of motion. The one selected here starts with Newton's laws applied to the collection of particles defining the rigid body. Any number of dynamics or physics books can serve as references. So they're saying the physics books can serve as references. I said, in this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed. Why? Why? So you're telling me that the physics of a non-rotating flat Earth are the proper physics. in a NASA document. Here we go. You can tell when they're older documents. Atmospheric refraction errors for optical instrumentation. Fun reading, folks. I'm telling you, fun reading. There you have it. Tells you technical memorandum, blah, blah, blah. Same thing. Preliminary report. October. What do we got? See? We're backing up. 1953. White Sands Proving Ground, La Cruces, New Mexico. Where's Area 51? It's in New Mexico, I know, but I don't know where. So, anyway, here we go. Look at this here. Just wanted you to see the signatures, real signatures. Dr. Fred Hansen, Dr. J.W. Molnar, or whatever. James C. McNatt, Lieutenant Colonel, United States Air Force. Thomas W. Morgan, Major, United States Air Force. Systems and Engineering Branch, Flight Determination Laboratory, White Sands Proving Ground. All here, right? Dr. So-and-so, Dr. So-and-so, General so-and-so. I guess they're stupid. This document was not to be seen. This document contains information affecting the national defense of the United States within the meaning of the espionage laws, Title 18 U.S.C., Sections 793 and 794. Its transmission or the revelation of its contents in any manner to an unauthorized person is prohibited by law. So this was classified in the 1950s. It's talking about basic equations for atmospheric refraction and all this stuff. It says, here, now I want to point this out. Present equations hold for any altitude. Everybody see that? I don't have time to read all of it. Present equations hold for any altitude. All right, let's see what they're talking about. Table of contents, introduction, validity of flat Earth assumption for atmospheric calculations. Validity. You know what validity means? Something that is a solid fact. Let me back up. Remember, present equations hold for any altitude. So some of this study of basic atmospheric equations, this is for any altitude. And this is the introduction. This is the table of contents. Introduction, the validity of flat Earth assumption for atmospheric calculations. If it wasn't flat, if the Earth was not flat, why would you start off a classified, under threat of law in the Espionage Act, why would you classify that? It's all here, folks. Introduction here says a comprehensive study of atmospheric refraction errors for optical instrumentation. What is it based on? Based on a flat Earth assumption, will be published subsequently. The relative mass of the atmosphere at any elevation angle is given approximately by the cosine of the elevation angle. I may be pronouncing some of this wrong, but listen, this relationship is correct for a flat Earth and a flat atmosphere. This relationship is correct for a flat Earth and a flat atmosphere. And they're going to publish these results. So we just saw one document say, this is the correct underlying physics, flat non-rotating Earth. We see this document right here say, this is correct for any altitude. I just want validity of flat Earth assumption. Validity. They're not saying, okay, see what some of them, this is what some of them say, that the flat Earth assumption is just to simplify things. But what this is saying is this so-called flat Earth assumption is valid. It's valid. Do you see it? Zoom in on it a little bit just so you see it. Validity of flat Earth assumption. Just so you know, the definition of validity. The quality of being logically or factually sound. Let's keep going here. Assumption. And anyway, let's just say that they didn't put in the validity. They just used the word flat earth assumption. You hear that a lot. Well, the assumption, a thing that is accepted as true or is certain to happen without proof. I mean, we don't even need proof of this anymore. This is what is assumed to be true by the scientific community, by the governments of the world. What's this one? This is NASA's Technical Memorandum, NASA.gov, mathematical model of a CH-53 helicopter. You guys know a helicopter pilot, right? So here's the NASA manual on that. Ames Research Center, Moffett Field, California. Equations of motion. The helicopter equations of motion are given in body axes with respect to a flat, non-rotating Earth. Meaning the helicopter takes off, it doesn't have to worry about the Earth spinning below it. Here's another one, vision-based mobile target geolocalization and target discrimination using Bayes detection theory. Oh, it's a mouthful, right? This is a more modern, I can't remember the year on this one, but anyway, you see this is the Academy Center for the United States Air Force, U.S. Air Force Academy, UAS research, and this is for targeting for unmanned vehicle aerial vehicles targeting manual. It says the objective of geolocalization problem is to estimate range to target, which can be estimated using the flat earth model shown in figure 2, which would be this little thing right here. No curve. Do you notice? The flat earth model. And your little aerial craft locating a target. Now, if this line was curved here, as it does, 8 inches per mile square, that line is going to intersect at a different point. I'm not a geometry teacher, but that I know. Maybe it's just from golf, right? Flat earth model. Range estimation using flat earth assumption. Unmanned vehicle targeting manual. From ResearchGate, but of course we showed you, United States Air Force Academy. Does everybody see that? Look at this. A key element in determining point-to-point acoustic transmission is modeling the variation of effective speed and sound through the lower atmosphere. Oh, did I forget this? Oh, yeah. Army Research Laboratory. This is another one. Calculating low atmosphere profiles, sound speed at night. So calculating sound speed. All right, pretty important stuff. It says to briefly examine short-range acoustic attenuation at night, we use low atmosphere profiles of wind speed, temperature, relative humidity, shown before as input to a flat earth, non-turbulent acoustic propagation model called the Windows version scanning fast field program. Propagation of electromagnetic fields over flat earth. Army Manual, February 2001. You can say, oh, Pastor D, the 1950s stuff and the 1960s stuff, oh, they just didn't know. They've learned stuff since. Right? Nope. They tell you right here. And you go into the manual. Here's the table of contents. It says comparison of principal fields from an ideal dipole oriented perpendicular to a horizontal and homogeneous flat earth. Army Manual. They tell you right here, it's assumed that the transmitting antenna and target or receiver are located above but near the surface of a flat idealized earth. Over and over again. I mean, I could do this. Guys, I could do, look, here's another. I even forgot. I thought we were at the end. Here's another one. Closed form solution for ballistic vehicle motion. Ballistic vehicle motion. A closed form solution is developed for the motion of a ballistic vehicle entering the atmosphere over a flat, non-rotating Earth. Frank J. Barbera, Cayman Sciences Corporation, Colorado Springs, Colorado. Closed form solution for ballistic vehicle motion. Meaning we got to know where this thing's going to come down. payloads for spinning projectile. Army. Think you need to know where artillery is going to land? Look here. Projectile flight dynamics. A 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. The assumption of these equations assume a flat Earth. These equations, a whole bunch of math we're going to do. BG Karpov experimental observations of dynamic behavior of liquid-filled shells. U.S. Army Ballistics Research Laboratory, Aberdeen Proving Ground, Maryland, August 1961 is a reference to this. But he says, and again, a projectile. You want to know where that artillery round is going to land. And what this study is, the one that has a solid explosive versus one that has a liquid payload. They're talking about chemical weapons or biological weapons. So they want to know, figure out the equations. So a 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. Again, why would you do unicorn math? Why would you do Thor hammer math if they don't exist? Why would you try to calculate ballistic missiles, unguided rockets, shuttle landings? Why would you base all your equations, all of your science on a flat Earth, non-rotating, non-moving, stationary atmosphere if it doesn't exist no more than a unicorn or Thor's hammer?